Good afternoon, beautiful people. Today we are going to look at calculus as it affects definite integrals. So we're going to look at definite integrals. Understand one thing about integration. Integration is already working, when we integrate, we're already working with the first derivative of the function. So when we integrate, we are doing two things. The first thing is to change the first derivative back to the original function so that it goes back to where it came from. Or we are actually determining the area under the curve. So for this section, we are going to look at the first derivative of the function we have and the other variables given to us are values, and then we will use it to figure out the original equation that gave this first derivative. So first things first, we simplify. They told us that this is the first derivative, so we can rewrite it as the integral of x minus 3 and x plus 1 dx. If it is the first derivative and we want to return it to the original function, then it is the integral that we are looking for. Now, just like every other calculus problem, before you can go further, you need to simplify what you have inside. So simplify this to be a common function. So we simplify this. If we simplify this, it gives us x squared, x and minus 3x gives us minus 2x, and then minus 3 dx. So this is what we are going to integrate to get the function. So to get the function here, we integrate this. So when we integrate this, we have x to the power of 3 divided by 3. Remember, it is n plus 1 over n plus 1. So 2 plus 1 over 2 plus 1. Then here we have n plus 1 over n plus 1. So we have negative 2x to the power of 2 over 2. And the derivative of the constant is that constant and x. Remember, because it is indefinite, no interval was given, we add our constant of integration. So we have plus c. We add our constant of integration. So that this has given us x cubed over 3. If we simplify, minus x squared plus 3x plus c. So this is what we have here. So the integral of this is this. Remember, we are coming from the integral to the original function. So in a nutshell, this is our f of x. This is the original function that we are working on. What do? We can't go further because we have an element of c and we don't know what that is. So it is not a full function. So that is when we now go back to the value that was given to us. It's a coordinate. F of negative 3 is equals to 5. It means that when x is negative 3, for that function, y is 5. So we can use that to get our constant of integration and then get the function. So we plug in. F of negative 3 means y is 5 when x is negative 3. When x is negative 3, y is 5. So that's why this. When x is negative 3, y is 5, so we have negative 3 squared plus 3 times negative 3 plus c. Let's simplify this. So give me 5. This is negative 27 over 3. This is 9, so we have minus 9. Minus another 9 plus c. So going forward, let's complete the simplification to get our c. So negative 27 divided by negative 3, so we have 5 equals to negative 9, negative 9 plus c. So this is negative 27. Coming over becomes positive 27, so c will be 27 plus 5, which will give us 32. So c is 32. Therefore, the function itself that gave this first derivative will be x cubed all over 3 minus x squared plus 3x plus 32. So this is the function, and our constant of integration is 32. So this is the process we go through. Remember, when you are given the first derivative and you are asked to get the function, understand that they are asking you to integrate, and this is the way to it. Thank you for having me. I'll see you.